Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain you about the velocity ratio of the belt drives and slip and creep of the belt drives. So in the velocity ratio of the belt drives, there are two types of belt drives, that is the simple belt drive and the compound belt drive. So we used to take the velocity ratios for both the belt drives, that is simple belt drive and the compound belt drive. And next we need to see the slip of the belt drive and creep of the belt drive. So this is my 50-second lecture regarding to the subject kinematics of machinery. So our topic is on velocity ratio of the belt drives. So to find the velocity ratio for the simple belt drive, so first you need to take the simple belt drive, that is having one pulley for one shaft only. So there is only one pulley for one shaft. So that is of the simple belt drive. So it is the ratio between the velocity of the drivers so our topic is velocity of ratio of the belt drive. So it is the ratio between the velocities of the driver and the follower. So it need to be taken for the driver and the follower. So the follower has been taken also as driven follower. Driven pulley. Let small d1 be the diameter of the driver. So we are assuming the notations here. So small d1 is taken as the diameter of the pulley, that is driver pulley. Small d2 is taken as diameter of the follower pulley. So it is taken as the diameter of the follower pulley. And next, capital N1 is taken as so the length of the belt, that is speed N1 is taken as the speed of the driver in RPM. So we would like to take it in the RPM, and capital N2 be the speed of the follower in RPM. So N1 and N2 can be taken as the driver and the follower speeds. Then we need to take the length of the belt that passes over the driver in 1 minute. So whenever 1 minute is taken, so the time constraint is taken, we need to take the length of the belt that passes over the driver. It is taken as pi into d1 into n1. So pi into small d1 into capital N1. Then similarly, we need to take the length of the belt for the follower also. So that is pi into d2 into n2. Pi into small d2 into n2. So it is taken as pi into d2 into n2. Then we need to take the length of the belt passes over the driver in 1 minute is equal to the length of the belt passes through the follower also. We need to take the both one for the follower as well as the driver. Then we have find the pi into d1 into n1 is equal to pi into d2 into n2. We need to equalize these both ones. Then the velocity ratio is taken as. Then we need to cancel these ones. So pi and pi should be cancelled down. Then n2 by n1 is equal to d1 by d2. So this is the velocity ratio which is obtained from the equation. So that velocity ratio is used to obtain from the equation. Then when the thickness of the belt is considered, that is small t is considered, then the velocity ratio can be taken as. So when the thickness is considered over that, then the velocity ratio can be taken from. So then the velocity ratio can be taken as n2 by n1 is equal to d1 plus t by d2 plus t. So the thickness has been added to both the diameters. So that is has been added to both the diameters. There we can find the thickness of the belt drive. So that can be taken as N2 by N1 is equal to D1 plus T by D2 plus T. Then we need to find the velocity ratio for the compound belt drive also. Then the velocity ratio of a belt drive may also be obtained as discussed. So this can be obtained as below. So we know the peripheral velocity of a belt drive. So we know the peripheral velocity of a belt on the driven pulley. Then velocity ratio for the driving pulley can be taken as. So the velocity ratio for the driver pulley can be taken as. So then the peripheral velocity for the driving pulley is V1 is equal to pi into D1 into N1 by 60, that is meters per second. So generally this velocity has been taken in the meters per second only. Then the peripheral velocity of the belt on the driven pulley. So the peripheral velocity of the driven pulley can be taken as V2 is equal to pi into D2 into N2 by 60. That is for the second pulley we are taking it as N2, and for the second pulley the diameter is D. Therefore we are taking it as pi into D2 into N2 by 60. Then when there is no slip, so there is stiffness in it, so there is no slip. V1 is equal to V2. The velocity for the driving pulley is equal to the velocity for the driven pulley. Then we have to take it as pi into D1 into N1 by 60 is equal to pi into D2 into N2 by 60. So after equalizing this, they have cancelled. That is pi in pi is cancelled, and 60 and 60 has been cancelled. Then we have obtained D1 N1 is equal to D2 N2. Then we use it to take it as N2 by N1 is equal to D1 by D2. So that is the obtained equation. Then in case of the compound belt drive, so in case of the compound belt drive, the velocity ratio is given as, so then velocity ratio will be taken. So here we are going to take the only two pulleys, that is driver and the driven. But in the compound belt drive there is idle pulleys, so we have to take the idle pulleys also into consideration. So then it is obtained as, so taking four pulleys here, so the velocity ratio is n4 by n1 is equal to d1 into d3 by d2 into d4. So here n4 is the driven pulley and n1 is the driver pulley, and diameter of the first pulley into diameter of the third pulley divided by diameter of the second pulley into diameter of the fourth pulley. So ఇక్కడ velocity ratio కాంపౌండ్ బెల్ట్ డ్రైవ్ తీసుకునేటప్పుడు ఇక్కడ వచ్చి ఈవెన్ నంబర్స్ ఉండాలి, పైన వచ్చేసరికి కింద వచ్చేసరికి ఆడ్ నెంబర్ ఉండాలి. సో డయామీటర్స్ లో కూడా పైన వచ్చేసరికి ఆడ్ నెంబర్, కింద ఈవెన్ పుల్లీస్ అనేవి తీసుకోవాలన్నమాట. అలా తీసుకుని మీకు ఈజీగా గుర్తుంటుంది. సో we have to take, so if we have taken 6 pulleys, then it is taken as n6 by n1 is equal to d1 into d3 into d5 by d2 into d4 into d6. So that depends on the pulleys we have taken. So that depends on the pulley we have taken. Then speed of the last driven by speed of the first driver. So this is taken as speed of the driven pulley by speed of the driver pulley is taken as product of the diameter of the drivers by product of the diameters of the driven pulleys. So it is taken as n4 by n1 is equal to d1 into d3 by d2 into d4. So that is the for the velocity ratio of the compound belt drive. So this is for the compound belt drives. Next we have to take the slip of the belt. We go to the next topic, that is slip of the belt. So what is meant by the slip in the belt drive section? So what is meant by slip? So that is if the forward motion of the driver without carrying the belt with it, it is called as the slip of the belt. and is generally expressed as a percentage. That is the looseness according the belt is called as the slip of the belt. When the fully efficient when the full power or efficiency has not taken to the belted drives. So that is meant by the slip of the belted drive. So it is taken as the slip of the belted drive, and the results of the belt slipping is to reduce the velocity ratio of the system. So it is to reduce the velocity ratio of the system, and as the slipping of the belt as the slipping of the belt is a common phenomenon, thus the belt should never be used, and where a definite velocity ratio is of importance, as in the case of hour, minute, and second arms in a watch. So each and every case should be very important in the situation. Then, thus the belt should never be used with a relative velocity. So we have to take it as S1 and S2. So S1 is for the driver and the belt of the slip. So the slip for the driver and the belt, and S2 percentage is for the slip between the belt and the follower. So it is for the belt and the follower. Then the velocity ratio of the belt passing over the driver is taken as, so the velocity ratio has been taken as for the driver per second, that is small v is equal to pi into d1 into n1 by 60 minus pi into d1 into n1 by 60 into s1 by 100. So this is the formula, and we have to take the common point, that is pi into d1 into n1 by 60 into 1 minus s1 by 100. That is the modified formula, and this is taken as first equation. So this is taken as the first equation. Next, the velocity of the belt passing over the follower per second. So this is taken in the follower, and similarly it is taken as pi into d2 into n2 by 60, that is velocity minus velocity into s2 by 100, that is velocity into 1 minus s2 by 100. Then substituting the value of v from the equation 1. So substituting the value in the equation 1, we get pi into d2 into n2 by 60 is equal to pi into d1 into n1 by 60, and to the slip of the driver and slip of the follower. Then we need to cancel the pi value and the 60 value. In total we get n2 by n1 is equal to d1 by d2 into 1 minus s1 by 100 into 1 minus s2 by 100. Then neglect the S1 into S2 by 100 into 100. So we have observed it as D1 by D2 into 1 minus S by 100. So this is the final value for that one, that is D1 by D2 is equal to 1 minus S by 100, where S is equal to S1 plus S2, that is total percentage of the slip is taken as S. Then if the thickness of the belt is considered, so when the thickness of the belt is considered, then it is taken as n2 by n1 is equal to d1 plus t by d2 plus t into 1 minus s by 100. So this is the value for when the thickness is considered. So that is about the slip of the belt. So slip of the belt is considered as d1 by v is equal to d1 by d2 into 1 minus s by 100. When it is takes the thickness of the belt is considered. So when the thickness of the belt is considered, then it is taken as N2 by N1 is equal to D1 plus T by D2 plus T2 1 minus S by 100. Then we need to take the creep of the belt. So this creep of the belt is occurred as the relative motion between the belt and the pulley. So when the relation between the that is relative motion between the belt and pulley is to reduce the speed of the driver pulley or driven pulley. So that is used to decrease the speed of the driver or driven pulley. So when the bolt passes from the slack side to the tight side. So slack side means the top side portion of the belt drive, the open belt drive or closed belt drive, and tight side is the lowermost part of the belt drive. So this is obtained as, so a certain portion of the belt is used to get extended and it contracts again when the belt passes from the tight side to the slack side. It is then contracted to the slack side from the tight side. Then, due to the changes in the length, due to the several changes in the length, so there is a relative motion between the belt and the pulley surfaces. So this relative motion is termed as the creep. So the looseness is called as the creep in that one. Then it is taken as, so this relative motion is termed as the creep, and the total effect of the creep is used to reduce the slightly the speed of the driven pulley or the follower pulley, and we have to consider the creep. So considering the creep, the velocity ratio is given by, so the velocity ratio is taken as N2 by N1 is equal to d1 by d2 into capital E plus sigma root of sigma 2 by E plus root of sigma 1. Here sigma 1 and sigma 2 can be taken as the stresses in the belt on the tight side portion and the slack side portion of the belt. So sigma 1 and sigma 2 is taken as the tight side portion stress and the slack side portion stress in the belt drive. And E is the Young's modulus. So this is the value for R. The equation for the creep, that is creep of the belt, that is N2 by N1 is equal to d1 by d2 into E plus sigma 2 by sigma 1. So here it is considered as the sigma 1 and sigma 2 as the stress in the tight side and slack side. And capital E is taken as the Young's modulus. So it is taken as the Young's modulus portion. Then we will take a problem on the slip of the belt drive. So this is the question given. So first to note down the question. So this is simple problem regarding to the slip. So first of all, study the question and gather the information from that question. Then we have to solve the problem. So first of all, study the question. So an engine running at 150 RPM. So 150 RPM drives a line shaft by means of a belt. Then the engine pulley is 750 diameter, and the pulley on the line shaft is 450 Then a 900 diameter pulley on the line shaft drives a 150 diameter pulley key to a dynamo shaft. So that is key to a dynamo shaft. Find the speed of the dynamo shaft when there is no slip and there is slip of 2% at each drive. So when there is a percentage at each drive. So this has to be taken. So this is a compound belt drive arrangement, and we have to take the pulleys based upon that. So diameter and the speed have been taken. So they have given the speed of the driver pulley, that is N1 is equal to 150 rpm, and they have given the diameter of the first pulley, that is 750 So this is the diameter of the first pulley. So this is the engine shaft, which is of 750 and diameter 2 is of 450 That is, this is the second diameter pulley, which is of 450 and diameter 3 is of 900 So this is of 900 and before it is given as 150 This is the driven pulley, that is follower pulley, which is of 150 So this is compound belt drive, and we have to take this slip as S1 is equal to S2 is equal to 2%. So we have to draw the diagram also. Then you have to proceed for the problem. So first of all, when we have to take when there is no slip. So when there is no slip in the belt drive, you have to take the equation. So when there is When there is no slip, we have to take it as N4 by N1 because there is 4 pulleys. So total there are 4 pulleys, that is why we are taking it as N4 by N1 is equal to D1 into D3 by D2 into D4. Then from the formula we have N1, but there is no N4, so they didn't given the N4. So we have to simply put it as empty, that is N4 by 100 is equal to, they have given the all diameters. So they have given the D1, D2, D3 and D4. So it is taken as 750 divided by 450 into 150. In total, it is taken as, that is N4 by 150 is equal to 10. Therefore, N4 is equal to 150 into 10, that is 1500 RPM. So it is the answer. So this is the speed of the driven pulley. And next we have to take the, with the slip condition there is, when the slip is at 2%. So when the slip is of 2% at the each drive. So we have to take the same formula adding the slip conditions, that is 1 minus S1 by 100 into 1 minus S2 by 100. So in total take substitute the same values. So when there is slip at 2%, we does not have the value of speed of the driven pulley, and the slip is taken as 2, that is 1 minus S1 by 100 or minus S2 by 100 is taken as value as 2. Then the obtained value is 9.6. So N4 by 150 is equal to 9.6. So that is 150 into 9.6. So in total, we got the speed as 1440 RPM. So comparing to the first one, it is somewhat lesser. That is 60 RPM is lesser than the slip when there is no slip. So this is the difference for the without slip and with the slippage. So there is a sample problem on slippage. So by here I am going to end this class. Thank you.